But force C, two forces act on a particle as follows. Force F1, 30 Newton at 30 degrees, and force F2, 50 Newton at 120 degrees. Then you'll be told to find the magnitude and direction of the resultant force. Now, for you to get the magnitude and direction of the resultant force, you use the parallelogram law, isn't it? So for you to use the parallelogram law, you must resolve the force into its x component and y component. That is when you are able to use parallelogram law. So it means this side you must have x component of the force, that is f of x, isn't it? And you know the x component of the force is always given by the force times the cosine of the angle it makes with the positive x, isn't it? So f of x is given as f cos theta, isn't it? From trigonometry. When you get x, trigonometry, x is always r cos theta, and y is always r sin theta. And remember r, the radius, meaning that r is the magnitude of that force. R is the force. So this is the x component, this is the y. Are you seeing that? Meaning the x component of any force is given by f cos theta, if the force is f, isn't it? Then the y component of the force is given by f sin theta. So in that manner, you would have resolved the force into its respective x and y component, because when you resolve them, you will now be coming with the parallelogram law, isn't it? So that for you to get the resultant x component, you add all the x components, isn't it? For you to get the resultant y component, you add all the y components. So the first force F1, what is the x component of F1? It is f cos theta, meaning 30 cos 30 degrees. Are you see? 30 cos 30 degrees, you get x component. Are we together? What do you have? What is 30 cos? So this is for F1, what is the x component? Give me 30 cos 30, you get 25.5? Isn't it? Yes. Then what is the y component? That is 30 sin 30 degrees, isn't it? It is f sin theta. Are we together? 30 sin 30 degrees. And you end up with 15 Newton, isn't it? Yes. Are we together? You end up with 15 Newton. So the x component of this force is 25.98. The y component of this force F1 is 15. And remember, when you are now looking for the magnitude of this force F1, it's the Pythagoras theorem, isn't it? Meaning the magnitude of this force F1 is the square root of the x component squared plus the y component. Meaning if you get the square root of 25.98 squared plus 15 squared, you get back your force, 30 Newton. Are you seeing that? Are we together? You get back the magnitude, the force itself. You move to the second force, that is F2. What is the x component of this force F2? It is f cos theta, meaning 50 cos 120 degrees, isn't it? What do you get? Negative 25. Good, then you are done, isn't it? You move, what is the y component of this force? That is f sin theta, 50 sin 120 degrees. You get positive 43.30. And remember, you are dealing with degrees, meaning the calculator must be in D, isn't it? Good. So now we want the resultant x component, meaning you use parallelogram law, you add all the x components, isn't it? So what do you get with the resultant x component if you add all the x components? 0.9. Then if you get the resultant y component of this force, you add all the y components, you get 60.
Yes.
68.3, isn't it? 58.3 Newton, isn't it? The forces are in Newton. So from there, you'll be told to find the magnitude and direction of the resultant force, isn't it? So the resultant force is F itself, isn't it? F. Are we together? So what is the magnitude of F? The magnitude is the Pythagoras theorem, isn't it? Meaning F squared is x component and the square of the y component. F is like the radius r from trigonometry, isn't it? Are we together? So for you to get the magnitude of this force, you simply take the square root of both sides. So you get F is the square root of f of x squared plus f of y squared, isn't it? Which you get to be this squared plus this squared. You simply go to the, I will show you how to do it with the calculator. So just get me the answer first. Square root of f of x squared plus f of y squared, you have 58.3 58.3? 58.30. It cannot be the same as the y component. If this is 58.3,
58.31.
yes, it cannot be the same. You are trying to tell us the Pythagoras theorem that is maybe b is equals to c. How? Is the opponent is the same. You must use common sense, isn't it? 58.331. Then from there, you move on to the next one. That is the magnitude, isn't it? What of direction? The direction is the theta. We found the direction is given by the tan inverse of y over x. So this means it is f of y over f of x, isn't it? So that's how to get direction. And you must know the quadrant where that force is. The quadrant. So for you to determine the quadrant where it is, you simply can check. The x component is positive. So it means this is the xy plane, isn't it? So if f of x is positive, meaning that is the positive, isn't it? F of y is also positive. So that is the positive y. So it means it is going to meet here. That is the force. That's why it is, meaning it is in the first quadrant. Are you seeing how to get it? So you get tan inverse of f of y of this over this. Then you take an angle in the first quadrant because you are getting 4 different angles, isn't it? But the one you are looking for is the one in the first quadrant where both of them are positive. It's the one you pick. It's what you write. Is that okay? So what do you get it to be? What is tan inverse of 58.3 divided by 0.98? What do you have? $89.04 degrees. So you see, the magnitude of the force is 58.31, the forces were in Newton, then the direction is acting at 89.04 degrees. Are you seeing that? So you found the magnitude and direction. So the magnitude direction is, you see the Saturn force is 58.3 Newton at 89.04 degrees. Are we together? It is 58.31 Newton at 89.04 degrees. Now this is how to look for it in the calculator. When you are looking for an x component and an y component, x and y is like saying you are converting a Cartesian coordinate system xy into polar form r theta, where r is the force F. Are you seeing that? So you want the polar form of xy for you to get the r theta, meaning you go to the calculator, what is the polar form of xy? F of x, f of y, isn't it? To get there? Are we together? But now, here it means we are looking for x and y, the x and y component, isn't it? So you don't look for the polar form. Now we want to go back. We are looking for the rectangular form of r theta to give us x, y, x component and y component, f of x, f of y. So go to the calculator and press rectangular, then in bracket r. Your r is the force F. Your r 30. Go to the calculator and fill. What is the rectangular form of 30, 30 degrees? It will give you the x component and y component of that force. Rectangular form. What is the rectangular form of 30, 30 degrees? What is the calculator giving you? It is giving you x and y, isn't it? Don't use that calculator for Form 1 LCM. What do you have? What do you have? If you get the rectangular form of that, so you have the shape, you see the rectangular is here. Where is it here? Shape, you get the rectangular, then form of r theta. Your r is the force, that is 30, you shape, how many degrees? 30 degrees. So you see what you are seeing? X is 25 point. So it is giving you the x component, 25.98. And what has it given you to be the y component? 15. Then you go to the next force, the rectangular form of r theta. Can you put this next one and see what the calculator is giving you? Rectangular form of 50, 120. What do you get from the calculator? Rectangular form of 50, 120 degrees. It will give you the x and y component. You have? From the first calculator, you will only get one. Univariate. We are not dealing with that calculator here. You have? Yes. Press the values. Yes. You have the same thing, isn't it? 50, 120 degrees. 120 degrees. You don't need to put degrees, it knows because the calculator is in D. You get x to be negative 25. Is that what we have there? And here you have y to be 43.3. Are you seeing? But now, we've now added and we found the x and y component of the resultant force. So for you to get f, meaning you go to the polar form of xy, you now go to the calculator and you press what is the polar form of xy? What is the polar form of 0.98, 58.3? The polar form of xy. It will give you r, which is the magnitude, and it will give you theta, which is the direction. Can you put that in the calculator? The polar form of xy. What is the polar form of xy? Polar form of xy. We are not looking for the polar form. Polar is now out there. Put in the domain. We did that. Polar form, my friend, polar form of x is 0.98, y, there you have 58.3. What do you get? You get r, which is supposed to be 58.31. Then you get the direction, which is theta. Scroll, you get the value of theta, 89.0. Meaning those values you are to be found from the calculator. What you do here is to write the formulas. Are you seeing? If you don't write the formulas, you don't give the values without these formulas, meaning you are cooking out things. And that is unacceptable, isn't it? The formula is what they are telling us that you have the values and you have the formula, so you are using the calculator to substitute, but in real sense, you are using the polar form. So it means this is not part of the working. That is just a shortcut, which is not part of the methodology. Are you seeing that? It is only used to confirm whether you've done the right thing. This is the procedure. Is that okay? Good. So you must confirm whether you've done the